Okay, good afternoon. So, from unit number 5, already we have discussed laser beam machining, that is LBM, and yesterday we have discussed electron beam machining. Okay, now we'll go for the next one, that is the plasma arc machining process. Okay, again, this is the advanced machining process. This is belongs to the this thermal energy based non-conventional machining process. Okay, very few students join. We'll wait for 1 minute and then I will share my screen so that you can see my screen. One more thing is that Vankar sir, HOD of our department, want to take the meeting with the student, okay, some representative of student regarding this syllabus completion and other things. Okay, so in this regard, I will give uh, one girl student's name and maybe two or three from boys side. Okay, so they have to attend the meeting. Okay, where it's a schedule. Also, I will inform you. Okay, through the WhatsApp, so that that time you can attend the meeting with the HOD sir. Okay, you just as a CR feedback or the class feedback. Okay, HOD level. So in that, if you have any suggestion, okay, then you can inform according to the HOD. Sir. Actually, looking to the syllabus of all the subjects, I think near about 90% syllabus covered for the all subjects. Okay, maybe last chapter is going on for some subject like IE, IQ, and for my subject NCM and the plastic engineering, sir. I think one more chapter is remaining. So in an average, 7 8 lectures, okay, are required for each subject. Okay, so if we'll get the lectures 4 5 per week, okay, without changing the without hampering your project day, then I think we can complete our syllabus up to the maybe the up to the 5th May, or maybe up to the 10th March. Okay, so after 10th March, we'll take our ISC 2. Okay, 30 marks ISC, and during that 10 to 15 ISC plus we'll take the submission. Okay, whatever that assignment or the journal requirements are, that part also will cover in between that 10 to 15th May, so that after 15 to for example now yet we haven't received any circular or notice regarding your examination from university. Okay, whether it is online or offline, or whether it is MCQ based or written exam, that also we don't know. Okay, so that idea is not clear, but maybe the possibility is that MCQ based your exam will be there, online exam. Okay, so again, the timetable is not displayed. That draft also not displayed by university. Again, the that university form filling, that activity also not started. So by looking to this, all these things, I think maybe the last week of May, or maybe first week of June, your that final university exam, university may conduct. Okay, so if we'll conduct our IC2 in between 10th May to 15th May, and simultaneously if we take submission also. Okay, then from 15th May to maybe 25th May, or maybe up to your final exam, you will time for the preparation or for other things, for campus try, or for the job opportunity you can try. Okay, like offline campus try or the whatever. Okay, and simultaneously up to that May 15th May, you can complete your project also. Okay, so my suggestion is that to all students. Okay, up to 15th, you can finish whatever your write part or whatever your project work. Okay, after 15th May, please concentrate on your uh, future path. Okay, your career. Okay, don't think about this B part there. Okay, because this is your the last term. Okay, now your B, that you are graduated now. Okay, only that examination is remaining. Okay, so after 15th, you have to say or you have to focus on your career, your future. Okay, if you are not selected in good company, then search some offline campus drive or some exams. Okay, whatever possible. Okay, or whatever feasible also. Okay, but start now only, after 15th only. Okay, so up to 5th or 10th May we'll finish our okay they, if you go like this only, with this speed, then also 5 to 6th May, up to that our syllabus will over for all subjects. Okay, and you can take 2 3 days to write that submission part. Okay, how much you have to write? Only 2 pages per unit as assignment, or to journal you have to write. Okay, so complete all the things, and you can concentrate for the your future part. Okay, so that is my suggestion, and actually that will be good for you only. Okay, because suppose if this COVID-19 pandemic situation, if it will continue like this. Okay, and if you are taking the shelter of this, let it be, आता कोरोना आहे, बघू नंतर, बघू नंतर, तर असं जात पुन्हा वर्ष गेलेलं कळणार नाही. सो लगेच 15 तारखेनंतर, 15 मे नंतर तुमच्या करिअरचं काय बघायचं बघायचं. ओके, आपलं चारही सब्जेक्ट एकदम इझी आहेत. ओके, ऑल 4 सब्जेक्ट्स आर theoretical. Okay, so no need to worry about the that passing and all these things. Okay, so concentrate on your career, future uh, options. Okay, so that is from my side. Okay, now let us start our the main agenda, today's agenda, that is the new process, advanced machine process, that is the plasma. And if you see, attendance for this our lecture, or maybe the for all subject, okay, near about 15, around in an average 20 students are attending. Okay, out of 65. Okay, and we see the response, active response, active participation, or the positive response of our students. Okay, when I was teaching this some subject for the BA last time. Okay, yeah, that time also I have taken, I think, after completion of syllabus. Okay, offline. That means during the in class only I have covered all the chapters. But after that COVID, that lockdown started, no, in the last March and April. That time also I have conducted online 20 lectures, as just a repetition all this. Okay, that time students' response was very positive. Okay, near about, I think, out of say 81, near about 60 students that time they were joining. Okay, so that batch was different. Now, look into this your class. Okay, yesterday I have written that very poor response in this online lecture or other thing. Okay, परवा मी फक्त तुमचा कॉन्टॅक्ट नंबर मागितला होता मुलांना. काय ना निवांत, मी 50% मुलांचा कॉन्टॅक्ट मी स्वतःच लिहिलं. मी असे स्टुडंट काय करायचं आणि काय करणार पुढे जाऊन. ओके, क्लासमध्ये म्हणजे ऑफलाईन बाबा फिजिकली असेल ना क्लासमध्ये, त्या टायमाला काय तर बोलतात येत. आता ऑफलाईन ऑनलाईन काय कोण पुढचं ऐकतोय का नाही, आता कसं करणार. आता ते ओंकार गुंड जॉईन झाला किंवा ओंकार गोरे. ठीक आहे, ते कडपर्यंत आता गोरे तर काल लेक्चर संपल्यानंतर जॉईन झालं, काय करावं गोरे. असं करून आता राहिले की एकतर 5-6 लेक्चर मला काहीच बोलता येईना तुम्हाला. ओके. कुठली गोष्ट थोडं पॉझिटिव्ह करा. ओके. जे आहेत ते आता ही जी तुम्ही जेवढे जॉईन झाले तेवढे प्रत्येक जण माझ्या मते एक 90% लेक्चर तुम्ही अटेंड केलेले सगळे स्टुडंट. ओके. So I was discussing about the this plasma arc machine. Okay. So as we know that this plasma arc machining it is belongs to our advanced machining process. Okay, and today we are going to discuss about this plasma arc machining process. Oh, actually, this plasma arc machining or plasma arc machine it is preferred for the welding for application of purpose. So plasma arc welding we might be heard about this. Okay. Now the first question arises that uh, what is mean this plasma or how this plasma is generated. Okay, so generally as we know that gas molecule it consists of 2 to 3 atoms. Okay, gas molecule it contains 2 to 3 atoms. Okay, so when these molecules of the gas, okay, gas molecules, when it is heated up to a very high temperature. Okay, suppose that temperature maybe around 20 sorry 200 degrees centigrade. So that time these atoms actually from these uh, atoms from your that molecule, gas molecule, it separated out, okay, due to that heating uh, heating up to a very high temperature, and due to that atoms from the your gas molecules separate out. And then, when these atoms are heated up to a very high temperature, okay, maybe around 2000 degrees centigrade, so that time the electrons and the ions are actually dissociate from the your atom. Okay, whatever the atoms are there, okay, from that gas molecule. So after heating up to the very high temperature, electrons and the ions, okay, are actually dissociate from your atoms. Okay, so gas is heated up more than 2000 degrees centigrade, then molecules separate out as atom. So having the gas having 2 to 3 or more than that atoms, and at a temperature maybe more than 2000 degrees centigrade or more than that also. So that time electrons from the your molecules dissociate the that at from your the electrons are dissociate from the atoms, and that gas that time gas will be ionized. Okay, so whatever the molecules are there, no, it consists of the ions and uh, electrons. So that ionized gas will be. So whatever that ionized state is there, so this state of that your gas is actually known as plasma. Okay, once again I repeating. Okay, here I written that at a temperature more than 2000 degrees centigrade or 3000 degrees centigrade or more, your electrons dissociate from the atom. Okay, electrons from the molecules. Okay, that gas molecules you can okay, and dissociate from the atoms and gas ionized. Okay, and it consists of the consisting of the ions and electrons. So that state of the gas is known as is known as the plasma. Okay, now repeating that gas is actually heated up again 3000 degrees centigrade. Then this electrons actually dissociate from your this and this your called actually it is called a state of plasma art, a plasma state. Okay, okay. Then next characteristics of the plasma. Okay, actually it is a glowing ionized gas. Okay, it is resulting from the heating of the metal to a heating of metal up to a extremely high temperature. Okay, so it is again this plasma is composed of free electrons and ions from the main gas atoms. Okay, main gas atoms. Again, so gas in this plasma state becomes it has that is conductive property. Okay, electrically conductive property, and also it responds to the that magnetism. Okay, so this plasma actually it is that gas in the plasma state. No, it is called normally fourth state of the matter. Okay, as we know that the three state. Okay, solid, liquid, gases. So this after this these three state we have the fourth one, that is the plasma. So gas in the plasma state, it is called fourth state of the matter. So plasma is called fourth state of the matter. So actually this plasma is encountered due to the electrical discharges. Okay, so now how this much of heat is generated from the plasma. Okay, because we need uh, more heat, okay, to machine. So that how much that heat is generated from plasma, that we shall discuss now. Okay, now uh, working principle. So as we know that the source of heat generation in plasma is the combination of the ions and the electrons into the your atoms, okay, or the combination of atoms into the molecules. Okay, when this actually what are the molecules or that electrons when these separated atoms and electrons that ions and the electrons separated from the your atoms, when these electrons recombine, no, so that time heat is generated. So when these recombine, that is the recombination of the atoms again into the your molecule. So this that time it will liberate the bonding energy. Okay, and that is responsible for the increased kinetic energy of your atom or the molecule, which is formed by the due to the recombination. Okay, so due to the recombination of this electron and ions into the atoms, and these atoms into the then molecule. So because of this liberated bonding energy, because of this recombination of these ions and the electrons into the atoms and this atoms into the molecule. So liberated bonding energy, that time huge amount of heat is generated. Okay, so this because of this liberated bonding energy, which is responsible for the increase of kinetic energy of the, your atoms and molecule, which is formed due to the recombination. So temperature is generated around 33, 33 uh, thousand degree centigrade. Okay, that plasma temperature as high as. Okay, so this much of heat is generated in the earth. Okay, so that is why this temperature rises up to the 33 thousand degree centigrade. So because of this huge amount of heat that increase the temperature, due to that only huge amount of heat is generated, and this much of heat can be used for a cutting purpose, for any kind of cutting purpose, so which is not possible by other our conversion, that is oxy fuel cutting or oxy fuel gas cutting. Okay, so that kind of so uh, any kind of that thick material, okay, that can be cut by using the plasma arc cutting process. Okay, so we can cut any kind of material, okay, including those having the high thermal conductivity, high heat capacity, and good oxidation resistance also. Okay, so what are the temperature? That temperature that which is high temperature, that is useful. That is useful for the cutting of any material. Okay, having the high thermal conductivity, large heat capacity and good oxidation resistance. Okay, now material like aluminum, copper, and then stainless steel that can also we can cut using this plasma. Okay, okay. So actually, what happened conventionally, this thin material is cut by the oxy-fuel cutting operation. Okay, but when this material thickness reaches to a certain height, okay, and also when there is will have a good oxidation resistance like stainless steel. So these kinds of metal cannot be cut by the conventional oxy fuel cutting operation. So that kind of material you can cut uh, by using this plasma arc cutting operation. Okay, now this is a diagram of the plasma arc cutting. Okay, so please observe this diagram. Okay, then I will explain. Uh, you can see in this slide. Actually, there are different types of plasma arc cutting operations are here. So there are, you can see in the slide, there are two main configurations are there. So one is the non-transport mode, and another one is the transport mode. Okay. So there are two modes of the plasma arc cutting operation. Okay. And the second one is the transport arc cutting. Okay. So first you can see here this is the non-transport mode of the plasma cutting operation. So this is the you can also this is a cathode here. Okay, cathode that is negative terminal here. You can see and this is the so that nozzle it is used as a your anode here. Okay, because it is connected to your point terminal of the plasma gas. So this plasma gas is can surrounding to this whatever the plasma gas is flowing to your cathode. Okay, so this surrounding this cathode, that plasma gas is coming, and it is passing this with a velocity. So that high velocity plasma gas is passing through this your nozzle. Okay, through this your nozzle. So when it passing through this nozzle, no, that time it is ionized. Okay, that time it is ionized, and this plasma gas actually highly pressurized, high velocity plasma gas is ionized, and using this non-transfer mode, uh, any kind of metal, whether it is electric conductive or electric non-conductive, any kind of metal can be cut or machined. So this is non-transfer arc. Okay, arc that what are the arc between the electrode and the nozzle. So this is the arc is you can see this is the arc is generated between the, your electrode and this your electrode means the cathode and this your nozzle. Okay, so here is the cathode and the nozzle is connected to the your anode. Nozzle is connected to the, your this anode and the okay, and here one more point that electro thermal efficiency of this kind of non-transport arc mode of plasma arc machining is the 65 to 70% efficiency electrothermal, and it has a very low efficiency. That means then this efficiency is very low as compared to the another type that is transport mode. Okay, so that ionizes high velocity gas streaming toward the your workpiece when it is passing through the cathode, that electrode, and then your nozzle. So high velocity plasma jet is actually here it is ionized at that time. with ionized. Okay, so workpiece conductivity is not constant here. So any kind of material, any kind of workpiece material, whether it is conductive or non-conductive, any kind of material you can cut by this plasma non-transfer mode of plasma arc machine. Okay, but in the second one, no, transport arc mode, transport mode. I can see in the second diagram. Okay, electrode is there and the positive terminal is connected to your workpiece. Okay, positive terminal it is connected to the your workpiece. So here that main constant is that your workpiece should be here main concept is that your workpiece should be electrical conductive material. So this kind of transport mode can be used only for the electrical conductive material, uh, electrical conductive your workpiece material. Okay, so your plasma gas is coming. You can see as you can you have seen in the non-transport mode now. So same way, uh, plasma gas is connected. Sorry, it is coming flowing surrounding to this cathode. Okay, this electrode, and while it's passing through this it ionizes here in this zone. It is ionized while it is passing through this nozzle. It is ionized. Okay, so here electrical that thermoelectric efficiency kind of transport mode uh, is very. Okay, one notice I want to here want to inform you that uh, sir is going to send one uh, link, okay, along with some information of that at 3 o'clock today you have one session, okay, and before that 3 o'clock you have to register with the link and other details I will share onto the WhatsApp, okay, and that time during the registration you have to that company name, that means you have to write the college name, okay, that instruction I will share through the WhatsApp, okay. Now come to the our point. So I want to come with the transport mode. Okay, transport mode of this plasma arc machine. Okay, so here the case is that this transport mode of the plasma arc cutting you can use only for the electrical conductive uh, material. Okay, so when you that here you can see I was talking about this plasma arc is coming is coming surrounding to this electrode, and while it passing through this uh, here no, so that time it ionizes. Okay, when it passing through the nozzle it is ionized. So here its efficiency electrothermal efficiency is very high. Okay, that is 85 to 90% electrothermal efficiency is there for this transport mode or the this plasma arc nozzle. Okay, so here arcing is generated between your electrode and your workpiece. Okay, and arc heat of this coaxial flowing gas also. Yes. Okay, so that coaxial flowing plasma arc. Okay, so it actually maintain it is in the plasma state only. Okay, here I have written that also. Now that this plasma system now actually it can deliver up to 1000, okay, at about 200 volt DC.
Okay, this pressure should be more than 1.4 megapascal. So because of this, high pressure of this plasma gas, okay, this plasma velocity also is very high that time. So velocity is very high, and plasma gas can remove your molten metal from your due to the high velocity and high pressure. It can remove the molten metal from your workpiece surface. So this plasma gas velocity is maybe that several 1000 oh sorry 100 meter per second. Okay, so you can explore towards the movement of your plasma jet. So the high velocity of the plasma jet should lead to very high movement of the plasma jet. Okay, so the what is the uh, metal removal process is there. So that is by melting and vaporization, because as we know that huge amount of heat is generated and the temperature rises around 33 degrees centigrade. So this amount of heat can melt and vaporize the metal where this plasma jet actually touches or the your workpiece touches to on your workpiece metal. Okay, so here the plasma having temperature more than 33,000 degrees Celsius. Okay, see the temperature. Okay, due to that only it is called the state of the matter, fourth state of the matter. Okay, so here you can return. I have written that in this slide. So the amount of heat in the plasma, due to that it can melt and vaporize the metal where the material from the workpiece surface where this plasma jet actually touches on your workpiece surface. So it removes the metal by melting and vaporization, and because of this high velocity plasma jet, whatever this molten metal is there on or vaporized metal is there no, so it will blown off from that machining zone. Okay, using by using its high velocity plasma jet. Okay, again the point here is that the what are the plasma jet is, you know, it is constructed uh, constructed by the flowing gas sometime, or that shielding gas also. So it acts as a cooling agent. Actually, what are the shielding gas is there now? It acts as a cooling agent. Acts as a cooling agent. Shielding gas it and will be known as the plasma jet. You can see here shielding gas here. Second is and your plasma jet. Okay, nodal wall and the plasma jet. So this link is there between the nodal wall and your a mechanism from the work is previously, as I mentioned that it is that melting and the vaporization. Okay, and that molten metal it can be blown off by the high velocity plasma jet. Okay, so this is about the working principle. Now, the otherwise can go this plasma. Okay, so there there are other elements. So first one is the power supply, then gas supply, then gas supply is the plasma supply system. Then we have the thing,
cool down the nozzle, because as the pressure is punching, you have to cool down, cool the unstable element of the nozzle. Okay, so after one becomes the CNC machining, uh, maybe called by use of CNC machining, in copy the canvas from the workpiece metal, another important front there, there is a plasma, plasma torch. Okay, okay, generation of plasma, that is plasma torch. So these are the different elements. So talking about this plasma torch, there are different kinds of plasma torches are available in the market. So so you can see the in this right side here schematic diagram of the first one I have shown, that is the air plasma torch. Okay, so this in this type of plasma torch. Okay, so this is a carrier gas. You can see carrier gas is there here. Okay, and that carrier gas is coming. So this carrier gas or the plasma gas is coming. Actually, carrier gas is your plasma gas, and that is normally that carrier gas, it is used as a compressed air. So here compressed air is used. Okay, and after flowing, it is going to ionize, and due to ionization, plasma will be generated, and that is used for doing the cutting. Okay, and that the here we have to take care is that the order the air is, so that air should be uncontaminated. Okay, if this contaminated air is coming, or some moisture is there, no, so because of that the huge amount of huge temperature, so because of a huge temperature, it will damage the nozzle. Okay, if it contain that air contains some micro moisture, no. Okay, that time if temperature increases, then it will damage sometime nozzle. So that is why your air should be filtered and uncontaminated. Compressed air is used as a plasma gas in this kind of air plasma torch. Okay, so in this air plasma torch, it uses compressed air, and that ionizes and does the cutting action. So this is a nozzle. Here you can see this is a nozzle. So outside there is a sealing cap is there. Okay, just outside this nozzle, and there is a sealing cap, and in between this nozzle and sealing cap, there is a coolant water is used. Okay, so coolant water is the flowing, so that whatever this heat is generated in the nozzle, okay, that heat can be dissipated into the coolant water. Otherwise, what happen, it will, if the nozzle is heated up, no, for a longer time, then with a very high temperature, then due to that, the nozzle life may be reduced. Okay, so if you use the coolant to remove the heat from the nozzle, so its life can be enhanced. So through this gap on surrounding uh, to this nozzle, the air can be coming. Okay, and it is passing through this nozzle. Okay, okay, and that after ionization, okay, it can be used for the cutting operation. Then uh, actually, this diagram, it is taken by that weak agent. Okay, this PPT I used from that course. So this diagram you will get in the Gary Windeck the book. Okay, again there is a double arcing is there. Okay, double arcing. So arcing may be between the electrode and nozzle, and in between the nozzle and workpiece also. So there may be the double arcing is there. So arcing may be happening in between your electrode and the nozzle, and in between nozzle and the electrode.
sorry, a workpiece. Okay, workpiece and your electrode. Okay, so torch nozzle may be result in premature failure because of the double arcing. So double arcing between the electrode nozzle and nozzle workpiece. Okay, that is also possibility. So this kind of air plasma torch it results in the high degree of the tapered machine surface. Okay, and what are the machine surface or the cut surface on your workpiece, it shows the high degree of taper. So this electrode material here normally in this case electrode material which is used for this kind of the air plasma nozzle is the that hafnium or zirconium. Okay, okay, I have written that. Okay, hafnium or zirconium. Okay, and here tungsten electrode are not used because tungsten does not last more than a few seconds. Okay, so due to poor oxidation resistance. So if we use a tungsten electrode, so then it does not last for more than a few seconds. So because it has very poor oxidation resistance, so that is why tungsten is not used as a electrode metal in case of air plasma or air plasma torch. Okay, so only this hafnium and zirconium is used, which has 2 hours of life and it has a higher oxidation resistance. Okay, here tungsten electrode is used, but in case of if you use a air plasma torch, that time hafnium and zirconium metal you can use as a electrode metal. Okay, then second torch here type is the oxygen injected torch. Okay, so this is one is the oxygen second one is the oxygen injected torch. Here is a nozzle you can see. So here actually it is a nitrogen as a plasma gas. Okay, to avoid the oxidation of the electrode or to enhance the life of the electrode, as plasma gas here it is used as a nitrogen. And that oxygen actually to ejected downstream of the electron. However, it lower down the nozzle life, and it gives the higher material removal but poor sequences of cut edges. And commonly used this oxygen injector torch normally it is used for the mild steel plate cutting. Okay, and what are the presence of the oxygen in the air, it helps in increase the material removal in case of the oxidable materials like steel. Okay, then third one is a dual gas plasma arc. Okay, that time also nitrogen you can use. Okay, again that oxygen or CO2 or argon, hydrogen, etc. can be used as a shielding gas. Okay, and then we have the this water ejector torch. Okay, that is also again another type of this arc, sorry, torch. And normally water muffler is used. Okay, actually covering of the water around the plasma torch, and due to that it extends down the actually that water muffler. What is the function of water muffler? Actually it is a covering of water, okay, around your plasma torch and extended down to the your workpiece surface. So due to the small water muffler, it reduces the smoke and noise. Okay. Now this process applications and process performance we'll see in the next lecture. I request all of you, please write down your roll number in the chat box. Please write down your roll number.
Okay.